Okay, now let's see the second example here. A box contains 5 red balls, 3 blue balls, and 2 green balls. 3 balls are taken out at random from the box, one after the other without replacement. Find the probability that none of the balls is a green balls. Because we see here the keyword is without replacement, it means that the problem here is dependent events. So let's just try to draw the tree diagram first. So we'll have the first ball, the second, and the third ball. And then here we have 3 colors, red, blue, and green balls. Because here we just want to find the probability that none of the balls is a green balls, it means we can just consider about two colors, even though we have here 3 colors, but here green and non-green. Let's just say green as G, and then G to represent the non-green balls. So the first ball, the probability is green or non-green. The probability of green is green ball. There are 2 green ball, 2 out of 10. It means just 2 out of 10. And then this one, it means if green is 2 out of 10, non-green is 1 minus 2 out of 10. So it is 8 out of 10. You can also just write the simplest form here. And then for the second ball also green and non-green. This one also green and non-green. If for the first experiment we get green balls, it means for the second experiment we just have one more green ball, and then the NS become 9, right? Because we already take 1 without replacement. So the probability here is 1 out of 9. And then for non-green ball, because here we get green ball, it means for non-green ball we have 8, right? 5 red and 3 blue, so 8 out of 9, and S become 9. And here, if the first experiment we got non-green ball, it means the green ball still, we still have 2 green balls. It means the probability is 2 over 9. And then for non-green ball, because we already take 1 for on the first experiment, we already take 1 non-green ball, it means we have 7 more for the second experiment. So it is 7 over 9. It's easy, right? So for the third experiment, we still have G. It should be G, 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 G. So because for the first experiment we already get green, the second also green here, it means because we just have 2 green balls here, it means for the third experiment it is impossible to get green again. So it is 0. And then for non-green, the NS become what? We already took 2 balls, it means NS become 8. And then non-green, we have 8 here. And then if the first we get green, the second non-green, it means for here we have over 8. And then for green we have 1 more, right? Because here we get non-green ball. For the second experiment we get non-green ball. And then for non-green ball, again it is over 8. So green, non-green, it means non-green we already took 1 non-green balls, it means we have 7 more non-green balls, so we have 7. So just the same case here. Just the same case here over 8 because ns is over 8 for the third experiment. So for green, we get non-green, green, it means we have one more green ball. Non-green and green, it means we have 7 more non-green. 7, and then here non-green, non-green, it means 2, and here non-green, non-green, we have 6. So now we want to find what is the probability that none of the balls is a green ball. So none of the ball, we don't want green, so it means we eliminate this, right? For this one, non-green, green, so no, it means this way, non-green, non-green, and non-green. So this is the probability. So the probability is 8 over 10 times 7 over 9 times 6 over 8, or it is just equals to 3 over 4, right? So this is 4, 5, 4, 4. So it is 21, 3, 1. So it is 7 over 15. Okay, now let's try to find the solution without drawing the tree diagram. So let's just assume that we don't have this tree diagram and we want to find the solution without revert to this tree diagram. So the probability that none of the balls is a green ball, the probability that the green none of the balls are green balls, let's just say non-green balls, is equals to, so because this is the case is we 3 balls are taken out at random from the box, one after the other without replacement. It means for the first we take it 3 times, right? So for the first experiment, ns still 10, still complete balls, right? For the second experiment, ns become 9 because one after the other without replacement. So for the third, of course, it is 8. So now we just need to find what is here. Let's see. Probability that none of the balls is green balls. So we just consider about non-green balls. We have 8 non-green balls here. It means first experiment, the probability is 8 over 10. And then if we already took one non-green balls as the first experiment, it means for the second experiment, the remaining non-green balls is 7. And then for the third, 6. It is just the same as here, right? It's just the same as here, 8 over 10, 7 over 9, 6 over 8. So it should be equals to 7 over 15. So it is equals 7 over 15. But if you are not sure, you can just draw the tree diagram actually. But if you are already good in this concept, you can just imagine it and write the solution like this.